Okay, we ever take another integral from the Scranton Integration Bee 2015, problem 10. We have the integral from 0 to natural log square root of 3, arctan e to the x over e to the x plus e to the minus x dx. Okay, I think there is kind of actually a shortcut with this one if we just notice the similarity what we have here to cosh, but I don't really want to rely on formulas for this one, so let's just do this out. What I want to do for my first step is I was thinking we could clean up this if I just multiply numerator and denominator by e to the x, and then what we'll do is we'll just rewrite this. So I'll basically just leave the numerator as it is. We'll have this e to the x is inside the arctan, then over here we'll have e to the x dx, and then multiplying in this e to the x here, this is going to become, I'm going to write this as e to the x squared, and then this is just going to be a plus 1. And now the reason I set it up this way, we have arctan here that we need to deal with. And then let's forget about the input being e to the x for a second. We just know that if we have arctan and we take the derivative of this, the derivative of arctan is just going to be 1 over x squared plus 1. Well, the promising part here is we have our input e to the x, and then here what we actually have is like 1 over e to the x squared plus 1. So what we notice is we have the same pattern that we have here, this 1 over x squared plus 1, but now our input here instead of being x is e to the x, so we have 1 over e to the x squared plus 1. So when we actually take the derivative of this thing, arctan of e to the x, well, what happens is now we get something really similar. We get this 1 over e to the x squared plus 1, but then when you do the chain rule, you take the derivative of this, and we get here this e to the x. So actually what we have is we have our whole derivative right here, and so what I want to do is go ahead and make a u substitution. So for the u substitution on this, we'll just call our u equal to arctan of e to the x, just knowing that when we take our derivative, we get back all this other stuff. We get this e to the x dx, e to the x squared plus 1. So what happens is when we do the substitution, the whole thing is going to transform as this is just u and this is all just du, but we need to update our bounds. So first we'll take natural log of square root of 3. Plugging that in here, if we look at e natural log square root of 3, we can think of this as canceling and this becomes square root of 3. So what we're going to need here is just arctan of square root of 3, and that's going to happen at pi over 3. And then taking our lower bound 0, plugging that in, we're going to have arctan of e to the 0 is just 1. So arctan of 1, that's just going to be pi over 4. So then we can just go ahead and integrate this. We're going to get u squared over 2 using power rule, and we just need to evaluate it from pi over 4 to pi over 3. So first plugging in this upper bound, we're going to get pi squared here over 18. And then for the lower bound, plugging pi over 4, and we're going to get pi squared over 32. And then we just need to see if we can reduce this. What I can do is let's factor pi squared over 2 out of this. Then what's going to happen is this becomes 1 over 9 minus 1 over 16. We can get a common denominator here multiplying by 9 over 9, here multiplying by 16 over 16. And so putting this all together, we have pi squared over 2. 16 minus 9 gives me 7 over 144. And I think I'll multiply it back and write the final solution as 7 pi squared over 288. Okay, there you have it. Nice integral from Scranton 2015. Thanks everyone for watching. Have a good day.